page 3, which I believe now we're going to have 3 variables. Alright, so we have a candy store. So there's one problem, 2 parts. As they give me 2 different pieces of information. So I have a candy store that sells 2-pound boxes of chocolate for $10 a piece, a 3-pound box of chocolates for $12, and a 5-pound box of chocolates for $18. Right, sort of the general information I'm going to use for the entire problem. Alright, now part A is giving me some more information. 1 week, they sold 100 boxes of chocolate for a total of $1,246. They sold twice as many 2-pound boxes as 5-pound boxes. How many of each kind did they sell? Alright, so I want to know how many 2-pound, how many 3-pound, 5-pound. And so this is going to be my X, Y, and my Z. So I'm going to let X be the number of 2-pound boxes. Y, number of 3-pound boxes. And Z, number of 5-pound. So the first one, so the 3 pieces of information are kind of the ones I've highlighted. The first piece of information I'm going to use is I know they sold a total of 100 boxes, right? Some of them were 2 pounds, some of them were 3 pounds, some of them were 5 pound. And so if I add them up, X, Y, Z, they have to add up to 100 boxes total. Then the second one is the value. $1,246 was the total value of those 100 boxes. X of them were the 2-pound. Well, 2 pounds were worth $10 a piece. And so 10x is how much were the 2-pound boxes generated, how much value the 2-pound boxes were. 3-pound were $12, so 12 times Y was the value of the 3-pound boxes. And 5-pound were $18, so 18Z was the value of the 5-pound boxes. All right, and there's the 2 equations. They came from my totals. The hard part is the last one. And it is hard because what you want to do is it's counterintuitive to the way it's read. All right, so this is the tricky part. All right. They sold twice as many 2 pounds as... So they sold... You have twice as many 2-pound as 5-pound, which means my last equation involves the 2-pound and the 5. There's no Y involved. So somehow I have to get my 2-pound, which are the X values, make them equal to the 5-pound, which were my Z values. One of them have to be multiplied by 2. Right? One of them's twice as big as the other. And so to make them equal, I have to double one of them to make them equal. So the best way to do it is to use numbers. If I sold 10 of the 2-pound boxes, so if X equaled 10, well, remember, X is the 2-pound. I sold twice as many of those. So that means the Z would have to be half of that, right? And it would only be 5 of the 5-pound, right? Because I sold twice as many of the 2-pound than I did of the 5-pound. So if I sold 10 2-pound, I only sold 5 5-pound. So that means in order to make these equal, I have to double the smaller amount. And that's where it's counterintuitive for students. Students will want to put the 2 on the one that's already bigger. Well, I don't want to make X already bigger. It's already bigger. If I put the 2 on the X, then I'm making Z the bigger one. Z is the smaller number. I have to double Z to make it equal to X, because X is twice as big as Z. Right? And so that's the hard part. This was the hard equation. Then I have to write it in standard form, which means I have to move one of the variables over. And so I'm going to move the Z over and subtract 2Z and set it equal to 0. Right? Because if I subtract 2Z, that zeroes out, and I get a 2Z on the other side. There is my system of 3 equations. And like I said, the last one's the tricky one, because students want to do it opposite of what it is. And double check yourself. If you're unsure, like I said, plug a number in. So suppose Z comes out, so suppose you put 3 boxes of Z, well that means X should come out 6, and it does. It works in my equation. Right? If I plug 3 in for Z, the 5 pounds, so if I sell 3 5-pounds, I sell 6 2-pounds. Right? Because that's what X represents, and it works. That makes the equation true. So if you're ever unsure, plug numbers in and make sure they work out the way they're supposed to. Right? And so there's my system. And once you've got that, that's the hard part. Once you've got that, and then you have to remember to put it in standard form. So remember, you have to move the variables to one side and the constants to the other. Right? And so the first two equations were fine, but that last one, I had a z on one side and x. I had to move one of them, and I chose to move the z. Right. Once you've done all that, then the matrix it's a three set case, so it's going to be a 3 by 4. The first one is just 1, 1, 1, 100. Second one is 10, 12, 18, 1,246. The last one is 1. There's no y, so 0. Negative 2 for z and 0 for my constant. And so that's what you're going to plug into your matrix and row reduce, RREF. And when you do, it should come out a nice one solution case. All right, so it should come out 46, 31, 23. So x is 46, y is 31, z is 23. So they sold 46 2-pound boxes, 31 3-pound boxes, and 23 5-pound boxes. And this is also a place where you can check that you've done it right. They should have sold twice as many 2 pounds as 5-pound, right? I had 23 5-pounds. Twice as many would be 46, and so that does check that. So you can also check your final answer to make sure you set up that equation right. If you'd set it up wrong, then it would be the flip of that. All right, so make sure you, again, kind of make sure your answer is reasonable, and check your answer. All right, the second part of this problem. So I have the same first set of information. I still have my 2-pound, which are worth $10, 3-pound, which are worth $12, 5-pound, which were $18. But in a different week, so this is in a different week, they tallied the amount of chocolate. So they sold 285 pounds of chocolate for a total of $1,176. They sold as many 3-pound boxes as 2-pound and 5-pound combined. How many of each did they sell? So they're giving me different information. I'm still going to let X be the 2-pound boxes. Y is still going to be the 3-pound boxes. And Z is still going to be the 5-pound boxes. Alright, but this time they didn't give me number of boxes. So make a note, that's different. In the previous question, they sold 100 boxes. In this part of the question, they told me how much chocolate was sold. And each box has a different amount of chocolate. They sold a total of 280 pounds of chocolate. Every X box has 2 pounds, every Y box has 3 pounds, and every Z box has... So this time I've got to deal with my pounds of chocolate, right? 285 pounds of chocolate total. All right, not boxes. And so when I sell X, I sell 2 pounds of chocolate when I sell my X box. When I sell Y, I sell 3 pounds of chocolate, and when I sell Z, I sell 5 pounds of chocolate. So that one's different. It's not X, Y, Z. It's 2 pounds for X, 3 pounds for Y, 5 pounds for Z, for a total of 285 pounds of chocolate. Second equation, though, is almost identical to the last problem, except for the total changes. Right? But this is still 10X, 12Y, and 18Z, because the values are the same. The only difference is the total amount of money. All right, changed. Instead of whatever the last one was, which was 246, this one was 176. But those numbers in the middle, are the number of the value of X, Y, and Z, that's the same. So the only part of this equation that changed was that. And then the last equation, which again is usually always the harder one, as you have to put it together. All right, they sold as many 3-pound boxes as 2 pounds and 5. So I have all three variables, right? 3 pounds is my Y, 2 pounds my X, 5 pounds is my Z. And so Y, which is my 3-pound boxes, how many of those that they sold was exactly the same as the X and Y, X and Z combined, right? Combined means we add them. I take X and Z, when I add them together, is exactly the same as the Y. And so my last equation is Y equals X plus Z. All right, and so this one, again, I need to put it in standard form, so I'm going to move the Y over, subtract Y. And then I'm going to write it X, Y, Z equals 0, right? This is going to zero out. So X minus y plus z equals 0. And I get the 0 from this. That zeroes out. And then I just put it in the right order, right? We always have to order it x first, y second, z third, equal to the constant. Well, the constant is 0 in this case. And now I'm ready to go. That's the hard part. Now that I've got it all set up, now I'm ready to plug it into the calculator and let the calculator solve it for me. All right, so plugging it in the calculator, up top it's 285, 10, 12, 18, 1,176, and then 1, negative 1, 1, 0 for the last line. And then RREF, row reduce it. I should get my nice one solution. All of these will come out. We always make sure they come out nice one solution cases. All right, and this time I have 33, 48, and 15. So x equals 33, y equals 48. And so this week, they sold 33 of the 2-pound boxes, 48 of the 3-pound boxes, and 15 of the 5-pound boxes. Alright, and so that one takes up that page. That's a 3-set page. And again, you have to read the problems very, very carefully. Read the problems and if you're ever unsure, plug numbers in to make sure that they work. Alright, so kind of the double check that this one worked. Remember, the y, which was 48, should be the exact same as the x and the z added up. Right? And it is. If I take 15 and add to 33, I do get my 48. Right? So you can kind of do a quick check at the end. Did I get the right? Did the numbers come out reasonable? All right, and they did. All right, so we'll stop there.